Now, the next thing we're going to talk about is we're going to go back and revisit some of these connections and cables. So it's kind of going to be a little repeat, but remember, that's also reinforcement, and it's going to help you retain. So there's plenty of connectors and cables. Video adapters devices can support multiple cable types. So when you get a nice video card, it's not going to just come with HDMI. It'll probably come with HDMI, Thunderbolt, maybe a display port here and there, a DVI, who knows. So when we look at LCD displays, remember they use digital signals only, LCD, but some support old legacy analog. That's like your DVI, right? We just said DVI-A supports analog, which we're going to see in a second. This one is all analog. So when you hear video connectors, analog, the first thing you want to think of is VGA. Video graphics array is really the first connector we kind of used with old school CRT monitors and older projectors. And this is all about analog. So it's a legacy standard. It's not being used anymore. It's 15 pin. Done. Analog, 15 pin, legacy. Moving on. DVI. Now with the DVI, digital visual interface, it's designed to replace the VGA, and it supports digital only or digital and analog signals. So there's different types of DVI, and that is distinguished by the pattern that you actually see the ports. So they do have the DVI-A, analog only, just like its old representative VGA. Then we have DVI-D, which is single link and dual link, but they are only for digital signals. And then we have DVI-I, which we're always looking at the dual link, and that will allow both analog information and digital information over the same connector. And this is what you want to know and be able to repeat for the 1101 test. And that is A analog, D digital, I analog, and digital. Okay? Moving on. HDMI, high definition multimedia interface, the most common video connection for displays. And basically, it supports digital video and audio directly through the same cable. So that's beautiful. Versions support different bandwidths. This is the 4K, the 8K, and so on. So version 1.4 was 4K. 2 actually supports up to 10K. That's all that's going to be covered on your exam. I'm sure they may have newer versions at this point, but we're not focusing on more than we need to at this point. Display ports. What did I say about display ports, huh? What did I say? Anybody remember? Anybody remember?
I can't hear you!
That is correct. They are royalty-free. Royalty-free. That means that no manufacturer has to pay additional money to put a to put a display port into their laptop or desktop. So that really helps. Obviously, people love free, and it works very well. So it's a digital audio-visual interface developed by VESA. It's a display port, supports some cross-compatibility with DVI and HDMI. So display ports, like for instance, when I traveled a lot, they gave me a laptop from my corporation that only had a display port on the side. And I'm traveling to all these different conference rooms all through Chicago, New York, LA, and none of them have a display port on their projector. Of course they have HDMI. So I simply bought a little dongle which converts which converts display port to HDMI. So I plugged in the display port, then I plugged their HDMI into the adapter, and voila, I was able to connect and function correctly. So royalty-free is something they will want you to know for the exam. The maximum data rate for a 4-lane is 17 gigabits. Excuse me. So what we're getting out of a display connection is all the way up to 17 gigabits per second. and that's a lot of throughput. Thunderbolt. Here we see it again, right? Because now we're making sure you understand that some of these cables support video and audio. So Thunderbolt and USB-C, that's an emerging trend to start supporting displays. Right now, I have one plugged into my computer, plugged into one of these multiple displays that we're using here in our recording studio. It can carry HDMI and DisplayPort signaling, but most often seen and used with Thunderbolt 3. That's where you're going to see these cables. So you can see right on the cable, it's marked 3, which is 40 gigabit per second, and it's got the lightning emblem right on it. So you can see like, okay, it has the Thunderbolt lightning symbol that says Thunderbolt. A video adapter and converter we were just talking about. I told you how I converted from DisplayPort to HDMI, and this one is converting from Thunderbolt to DVI. So here's your Thunderbolt port. Here's the Thunderbolt connector, so you can connect into the port on the side of your laptop, and then it's going to convert into DVI. Video cards. Video cards is something that I'm sure a lot of people out here know about. Most of my students are very much into building gaming systems and things of that nature. So a lot of people know about this. If you're like me, not a gamer. I work too much on computers to play games on them also afterwards. So a video card, an interface between the graphics component of the PC and the display. There's two types of ways we can have video introduced into a PC. It can either be on a separate card, like you see here, which is awesome. This is a GeForce RTX. It's got built-in fans because it has so many GPUs, which are small processors for graphics, produces heat, so it has its own built-in fans. This is using our PCI, what? By what? By... That's correct, by 16. Thank you, Jeremy. So, when you plug this into a PCI by 16, that's what produces the graphics, which also talks to Microsoft's operating system and gives you this beautiful display to your monitor. Once we calibrate whatever resolution that this video card and your monitor can accept, we're going to produce the best visual display available. So it might use system CPU and memory. That's an onboard processor. So this is going to blow your mind, but graphics cards or adapters can be either integrated on the board, soldered onto the board. That's where you're going to see the port directly off the board. And the GPU is going to be inside of the processor. So the graphics processing unit is actually built in. Intel, AMD, they have a lot of CPUs that have built-in GPU chips inside the processor. And this is going to be for most people that are browsing the internet, watching a movie on their laptop. That's fine. When you see something down in the right-hand corner, you're doing some serious gaming. I mean, you're probably in there working with 10 other people trying to take down a crazy airplane in some video or something. That's the type of graphics card you're going to want to use in a gaming party, right? I'm not concerned about that. I'm just internet browsing. I'm going to use an onboard or the GPU that's already embedded into my CPU. So there's the integrated cards we just talked about, onboard, usually on low-end PCs that don't care much about the video. Or it can be an add-on card, which is always going to be in a PCIe by 16 or higher expansion card. GPU, look at that, just brought it up. Graphics processing unit. It's a type of microprocessor used on dedicated video adapter cards or within a CPU with integrated graphics capabilities. It's like I just talked about that. It came. Isn't that amazing? I just love when that happens. So GPUs will have clock speeds. They will have, I don't know what the shader units are, but they have clock speeds. They have frame rates. They're always going to interface via PCI 16. At least one digital video interface, if not multiple. So it's probably going to be HDMI if there's only one, or it's going to be a whole bunch of other ones that can produce. Remember, Thunderbolt's in there too. Now, the software that's built into the video cards, video adapters, regardless of where they're located, is DirectX and OpenGL. So we're going to make sure that this has the program or firmware directly on the circuit board that can talk to DirectX, which is Microsoft's version, or OpenGL, which is another just open standard version for graphic communication. What tools can we use to configure this stuff up? Well, obviously we can always go into our display tools directly in our computer, which we'll be seeing and demonstrating all in the software portion. Or a lot of times, if they're not some high-end graphics card like we just saw down there, then we're just going to use plug and play. Plug and play will detect the card, install the driver, which is already in Microsoft's driver database if it's there, and then tell you what the native resolution should be for your monitor. It's seamless. We can also use the system firmware setup program to disable onboard video adapters. So what we're saying here is we can go into the motherboard software, which we're going to learn a lot about later chapters, and we can shut off our video display adapter. Again, I talked about this. So even if it's not broke, you don't want to plug in a brand new video card and a PCI by 16 slot and leave your integrated video on. Because your computer and certain programs may start to go, hey, which one of these things am I supposed to use? And then you're going to have errors. So if you are introducing a higher end video graphics card, you want to shut off the video port that was prior to your new card. That is a great idea, and that's also part of troubleshooting. All right. Settings such as resolution and so on can all be set in Windows Control Panel or just personalizing your device. Right? So we got Windows Settings, Control Panel. There's also vendor configuration utilities, you know, like with the card that actually you came with. And that can get in some really fine-grained tuning. So if you have software that came with the video card itself, that's probably your best place to really tweak, fine-tune your graphics card. Okay, that quick pause there was just for you to catch your breath, making sure you're doing retention is happening as we're talking. And then we're moving on to multiple displays. Now, multiple displays is a very important concept, especially right out of A+. You're probably going to get some type of Tech 1 technician role. That's when you're going to go and help people set up their desk for the first time. And when you're setting up their desk or cubicle, one of the most common situations that I come across, and that happens with colleagues now of mine, is they don't have their monitors positioned correctly. And I actually stopped a girl from doing this, and she thanked me a million times because she had a monitor set up. Let's say monitor A was on the left-hand side and monitor B was on the right. When she put them on her desk, ran all the wires, of course, she tied all the wires. It looked great. And then she plugged it in. When that occurred, they were out of tune, meaning she would use her mouse and to move from one monitor to the other, it was in the wrong direction. You couldn't go from the left side monitor to the right side by moving left to right. You had to go the opposite direction if you're seeing me that way, right? So besides going this way and going from one monitor to the other, which she wanted, it was going this way. So she's like, oh, I got to grab my monitor and pick it up and put it on the other side. And I said, no, hon, you don't need to do that. You can adjust all that in the software. So it's very important to know that. You can literally grab the monitor. You see how there's a monitor here and a monitor here? And I can grab them and drop them one in front of the other. So what if the one in the front says 2 and the other one says 1? Now I can use it to move my mouse correctly across both displays. You're going to look like a superstar when you do that. I'm just going to tell you now. It always impresses the people. And it's very much going to be part of your everyday setups. So you can duplicate, and that's kind of what I'm doing right now. So for my PC, I'm duplicating to an external monitor, and I'm seeing exactly on the other monitor what I see in front of me. Or you can extend. Extending means one of your monitors are not going to be a carbon copy of the second monitor. This way you can have things on the right-hand side monitor or on the left, and you can work with 2 different software programs at one time. And you can also show only half information on a particular viewing device, which is not very common.